Hey guys, what's up? Welcome back to Scoreline, and today I'm Ishanth, and I'll be teaching you everything you need to know about quadratics on the SAT. So I'll be running through uh, basic methods, advanced methods, how to find the roots quicker, how to find the sum of solutions quicker, product of solutions, different like forms like the vertex form, root form, transformations. I'll be running through all those problems today, and I'll also be uh, using just a piece of paper or a whiteboard. I won't be using Desmos just because I want to show you guys how you can do this by hand. You can use Desmos, it is a tool, but it's also important to be able to do it by hand. So I'll be showing you how to do it by hand today. And yeah, so let's start with the roots. So to find the roots of a quadratic equation, usually they'll give you a quadratic equation, and if it's easily factorable, then you could factor it and find the roots. But if they give you an equation, suppose like 5x squared minus 5x plus 1, this is pretty hard to factor out, or I don't even think you could factor this out. So if they give you that on the test and ask you for the roots, then you want to use the formula negative b plus or minus b squared minus 4ac divided by 2a. Many of you guys know this is the quadratic formula. And yeah, use this formula and you could find the roots. You mainly want to use this when the answer choices have square roots in them. Or, yeah, I mean, mainly if there's square roots and they give you answer choices with square roots, then use the quadratic formula. So your a is going to be 5, just coefficient in front of x squared. Your b is going to be negative 5. Don't forget the negative. It still counts. And then your c is going to be 1. So now you just plug it in. So negative 5, so that's positive 5 plus minus. B squared is 25. Then C times negative 4 is just negative 4, and then negative 4 times negative 5 is okay, so my apologies. I wrote the equation wrong. It's actually 5x squared minus 5x minus 1. So C is supposed to be negative 1. Anyway, so negative 4 times negative 1 is positive 4. Positive 4 times 5 is 20. And then divided by 2a, so divided by negative, oh no, sorry, wait, oh my god, I don't know what I'm doing right now. Okay, so 5 times 2, so that's 10. So if we simplify this, it'd be that, and then what you could do here is you could take out uh, the 9 from this, so it'd be 3 square root 5 divided by 10. Then you can go a step further and do half plus minus. Yeah, so this would be either this or this. They would both be the answer choices. So yeah, now I'll be talking about the next topic, which is going to be about, if I can erase this. So the next topic we're going to be talking about is the solutions for a quadratic equation. So if you want to know how many solutions are in a quadratic equation, a quick way to do that, so let me just write out the quadratic formula again. So this part, this section, not including the square root, this part is called the discriminant. And what the discriminant shows us is that if the discriminant is greater than 0, there's 2 solutions. If it's equal to 0, there's 1 solution. And if it's less than 0, then there's 0 solutions. So we could use this to solve a lot of questions that involve solutions for quadratic equations. So let's do some examples. Okay, so here I have a question up here. The quadratic function f of x equals 4x squared minus 12x plus k has one solution. What is the value of k, where k is a constant? So this is how we're going to dissect this. So it tells us it has one solution. What do we know? We know that b squared minus 4ac equals 0. That's one solution. And we're trying to find the value of c. We don't know what c is. So what we could do is we could plug in a, b, and solve for c because we know that this equation equals 0 because it only has one solution. That's as given in the problem. So here's the function quadratic equation. So we have this quadratic equation. I'll just put equals f of x here. So a equals 4, b equals negative 12, and c we're gonna keep k as a placeholder for c. So now we're gonna plug these into the discriminant formula equation, or just discriminant formula. So negative 12 squared, that's 144, minus 4 times 4, that's 16, and then c is k, so we're just gonna add k there, equals 0. Now if we add 16 to both sides, 16k, we're gonna get 144 equals 16k. And then 144 divided by 16, that's 9. So k equals 9. So your answer choice here would be D. So that's how I could use this discriminant formula to solve questions that either ask you for an unknown value or just state, like they'll give you a quadratic equation and just ask you how many solutions are in this quadratic equation. So this is how you could easily do those questions. Now I'll be moving on to more topics, and I'll also be getting more practice questions. Okay, so the next quadratic topic we're going to be talking about is the sum and, if I could, okay, sum and products of solutions. So here, these are going to be practice questions, by the way. So this is really easy. Um, this is probably like the quickest way you could do it. So for sum of your roots, sum of roots is going to equal negative b over a. For your product of roots, is going to equal c divided by a. That's all you got to remember. If you just remember these two things, you could solve any question that asks you for sum and product of solutions. So now let's look at this practice question. Zoom in. So it's asking us in the quadratic equation. Uh, Let me just erase this. So it's asking us in the quadratic equation 4x squared plus 8x plus 3 equals 0. What is the product of the roots? So what's the formula for the product of the roots? That'd be c over a. I gotta decrease the width on this. Okay. So that'd be c over a. We know that a equals 4 and c equals 3. 3 divided by 4, so it would be 0.75. That'd be your answer for this question. So just use the formula. You can find out the answer for that one. Let's look at the other one. So this is another question. It gives us an unknown value in the quadratic equation and it asks us to find it. And we know that one of the roots is -5. So for this question, so if we wanted to use the product of solutions for this, we wouldn't be able to because we don't know what k is. So a better choice would be to use the sum of solutions, which is -b/a. We know what b is, we know what a is, they're right here. And we know one of the roots is -5. So what we could do here is, so we know b is 9. b equals 9. A equals 2, and one of the roots, I'll just call it x1, equals -5. So if we use the formula, -9/2 equals -5 plus x2. So now all we have to do is solve for x. So we add 5. And if you guys are confused on why I'm adding these two roots, it's because this is supposed to be the sum of roots formula. So -b/a equals √1 plus √2. So that's why we're adding these two roots together. So we cancel the 5 there. That's 5 minus 9/2 equals x2. If we find the common denominator here, it'd be 10/2 minus 9/2 equals x2. So we'd get 1/2 equals x2. And now we know that the other root is 1/2, which is a. So that's how you solve this one. Just use the formula. It's just plugging in numbers, finding the unknown value. Really simple. Probably take you like 30, 40 seconds, even less than that. So yeah. Okay, so the last topic I'm going to be talking about for this video is standard form. So a standard form of a quadratic equation, that would be x squared plus bx plus c. Now this tells us a lot about a quadratic equation, or the parabola. If a is negative, so less than 0, it's concave down, and it has a maximum at its vertex. If a is greater than 0, it's concave up. I did not mean to make a mark there. Let's just, okay. If a is greater than 0, or positive, it has a minimum at its vertex, and it's concave up. The c value is the y-intercept for the function, and you could find c by multiplying both of the roots of the quadratic function, or it would just give you c right there in the equation. Sometimes it asks you to find what c is, and it will give you two roots, so remember this formula as well. To find the vertex, or the x-coordinate of the vertex specifically, you want to use the formula -b/2a. This will give you the axis of symmetry, which is basically the x-coordinate of the vertex. Or you could use the midpoint formula where you add both the roots or the solutions of the quadratic function and then divide it by 2. And if you want to find the y-coordinate for the vertex, you just plug in x to find y. So this is everything you need to know for standard form. And yeah, let's do some practice problems. I have some on this side. So let me zoom out. Okay. Okay, here. Let's do that. And then let me just move these aside. Okay. Let me move a bit. Okay. So this question asks us uh, which of the following could be an equation of the above graph. So we know it's concave down, obviously. So we know that a has to be less than 0. And there's a y-intercept at 4. So we know c has to equal 4 because that equals the y-intercept. So we look at our options. It can't be D or C. They have a positive A. We need a negative one. So it's between A and B. And we know the y-intercept is 4. So it can be A because it has a value of 2. So the only answer that would make sense is B. So you want to do uh, process of elimination for these types of questions uh, if you encounter them on the SAT. Next question. So this one is asking us about the coordinates of the vertex. So if you remember the formula, so let's just write down our values first. So we know the formula is negative b over 2a. B is 12, so negative 12. And then 6 times 2, that's 12. So that's negative 1. We know the x coordinate is negative 1, so we can eliminate c and d. But now we don't know what the y coordinate is, right? So we need to plug in the x coordinate back into the function. So 6, negative 1 squared plus 12, negative 1 plus 4. So negative 1 squared is 1, so that's just 6. Um, Negative 1 times 12 is negative 12. That's just plus 4. So 6 minus 12, that's negative 6. Negative 6 plus 4, that would give us negative 2. So we know our y coordinate of the vertex is negative 2. So the answer would be A, and we could cancel B. So that's how you'd find the vertex. Easy way to find it. It's a pretty important formula, so I suggest you remember that because there's a lot of questions that ask you about the vertex. Okay, so we have a quadratic function, and this question asks us, it models the height of a ball in feet t seconds after it is thrown in the air. And okay, I think I cut it out of this question, but it basically asks you, what's the maximum height of this ball? So for these types of questions, right? So just pretend there's a graph of the ball. So this is h of t, it's the height of the ball, and then the x-axis is just t. So the parabola is gonna look something like that, and then it'll land somewhere there. So this is really important because these are like real world application questions. So if it asks you for the time at which the ball is at its maximum height, that would be the x coordinate of the vertex. So that would just be the x coordinate of the vertex. The time at which the ball is at its maximum height. If it asks you what is the ball's maximum height or how high did it go, that's the y coordinate of the vertex. If it asks you um what time did the ball land, that's the solution, root 0 of the quadratic function. So basically the x-intercept. So I could have added this question, sorry. But it basically asks you what's the maximum height of the ball. I'll just write it here. Okay, so to find this, I just told you guys that the maximum height of the ball is the y coordinate of the vertex. So first we need to find, uh, yeah, let me write out the equation first. So we need to use the vertex formula, negative b over 2a, to find the x value, then plug it back in to find the y value. So negative 16 is the a, b equals 32. So you get negative 32 divided by negative 16 times 2, which is also negative 32. So you get 1. And now you could plug this in back. You could plug this back into the original equation to get the y value of the vertex. So 1 squared, that's just 1, so that's just a negative 16. 32 times 1, which is just 32. So you get 16 is the maximum height that the ball uh, went up to, I guess. So I hope you guys enjoy this video. I'll be posting more videos on SAT related stuff. I will add in some other stuff too, probably chem, and yeah, I hope this helped you guys. Next video, I'll most likely be talking about geometry topics because those are pretty hard for students, and that's where they usually lose points on the SAT for. So yeah, I hope you guys enjoy this video, and I'll see you guys next time.